Okay, good morning. Today is tutorial 7, and we're going to be looking at for loops today. Okay, so let's go ahead and create a new script. Bring it over here, paste it. Okay, so for loops, all right. And if you're looking at more, this is chapter 9 of that book. Okay, now let's save this. So again, I got the header. Tutorial 7. I'm just going to do it in downloads and call it for loops. All right, let me move this out of the way. All right, here we go. So, copy this. Got our main code. Let's get right into it. So, we're going to create a loop structure. Okay, it's basically a loop or a for loop does the same calculation multiple times. Okay, so we're going to do the calculation 10 times here, and you'll see this. So what you need to do is you can say for I equal 1 to n, and then y parenthesis I equals I times 2 plus n end. Okay, so in Matlab, this is the structure. You type for, then you have a space, identify a operator. Okay, it could be I, it could be J, it could be little n, it could be whatever you want. Okay, but it has to be different than your variables in your givens. Okay, here is I'm doing the number 1 to n, which is 10. So I'm going to do this code 10 times. Okay, I'm going to calculate y, which is I'm just going to multiply I times 2, and I'm going to add n. Okay, now I'm storing y. That's what this parenthesis I means. If you have a parenthesis I, that means you're going to build up y, and I'll show you that. Okay, so let me dock this and go down here. And I'm going to just type pause. You don't have to, okay? And I'm going to run it. Go into the doc downloads folder, okay? So right now, I is 1. So 1 times 2 is 2 plus 10, which is 12, okay? Now, I'm using pause just to show you how the code works, which is kind of cool. You hit enter, and it'll execute again, okay? So this for loop now is done. So it goes back up to the top. I is now 2. So it's 2 times 2 is 4 plus 10, which is 14. And you see how it's stored it in a matrix? It's stored. It's going to have so many columns. It's going to be one row. And then I can do it again. 3, 4, 5, 6, 7, 8, 9, 10. Okay. And then if I type y, it is now a matrix. You see this? Okay. If you type whose, it's 1 by 10. It's got 10 numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Now, if you didn't put parenthesis I in here, and I'm going to get rid of this, and I put a semicolon here, it's going to be the last number. It's going to be 30, which is 10 times 2, which is 20, plus 10, which is 30, okay? It didn't store any of it. Okay, so if you want to store your equations, then you want to do this, okay? All right. Hope that makes sense. Just very simple for loop. It does the calculations 10 times, and the cool thing is you can go up here and change it to 12, and then it will basically store that, okay? Cool. All right, let's keep going. Let's do another example. I'll copy and paste some of this. Here's another example. We got scores. which is 76, 45, 98, 97. Okay. I have a loop counter. Okay. You'll see here in a second why I'm doing this. I'm just saying, okay, count is 0. And then my n, the number of times I'm going to do this, okay, and that's for me. I'll just take that out. This is going to do the code, the length of scores, which is 1, 2, 3, 4. This is a built-in function in Matlab. It actually determines how big this is. Okay, so if I run this, if I take the semicolon out, you'll see that that number is 4. Okay, and an overwritten or overwrote this one. Okay, so probably I should do clear all in CLC. Okay, but it's going to overwrite it no matter what. Okay. All right. So now let's make the code for k equals 1 to n. And I'm saying I'm going to put an if statement, something we talked about last time. If the scores of k are greater than 90, we're going to increase our count. End. Okay. So what I did here is here's our for loop. Okay. We have 4, we have a space, we have a the for loop counter, which is k. That's going to go from 1 to n. And then what I did here is just said, well, just another example. Well, if the scores of k, so I'm going to look at each individual score. That's why I have parenthesis k here. Okay. So the first time this loop goes through, I'm going to look at 76 and says, well, if it's greater than 90, we're going to increase our count. But if it's not going to go into this if statement, right? Okay, so it should only give us 2 because there's only 2 times where this was working, okay? What I'm going to do is I'm going to put k here so you can see, all right? And I'm going to put pause, and I'll put this over here too, okay? So let's run this. So k is 1. It didn't go in the count, okay? Otherwise, you would have seen count because that was ahead of this, okay? Again, now when I click enter again, you should get a count and the k will be 3. Counts 1 because it checked 98. K is 4, okay? And the count is 2, okay? All right, so if I put the scores of k, because I want to, in this loop, I'm looking at one individual number, one individual score. That's what I want. I want to look at 76 first, and then it gets to this, and it goes back up to the top, and it looks at scores of 45. So let me run this again. See, we're looking at 76. Is that greater than 90? Nope. So it doesn't count. Now we're looking at 45. Is that greater than 90? Nope. But the next two, all right, we have 98. Well, now we've increased our count. K is 3. And then again, scores is 97. Our count now is 2. And we have K of 4. I can delete those. I'll put that on there. And so when we look at our count, that's 2. Okay. All right, so just a couple examples, and we can now spit that count correctly using fprintf to the command window. Count is 2. Okay. So very simple, just in summary here. Okay, we'll get a couple other things. Is simple for loop, identifying how many times it's going to loop. Here, I showed you the length of scores because that's how I usually do something. I want to do this 4 times because I want to look at each individual score. Okay. All right. A couple other things. I'm going to copy and paste this so you can get it. Understanding how long it took to do the loop. Okay. You can use this thing called tick and tock. Okay. So I just cleared everything, cleared my command window. I'm going to make the loop do it 10,000 times. Right before the for loop, I put tick. Okay. Here's my for loop. So I have 4 space I equals 1 to n. Here's my equation inside the for loop, and I'm storing y because I have parenthesis I here, okay? And I'm just saying, well, the equation is just I squared, that's it. Then at the end, put talk. Having tick and talk here will tell us the elapsed time. It took 0.01872 seconds to run this code, okay? And y is huge, right? 10,000 times. If we change this to 50,000, okay, it took a little faster. Okay, let's change it to, sorry, a little slower. Add another 0. Okay, 0.06. Okay, I don't know, let's run it. Add a couple more zeros. Okay, see, it's taking a little bit longer to do the code. All right, now watch. I can make it go faster by establishing the Y matrix ahead of time as not numbers. So this line right here that I just pasted in, if you know how big your for loop is going to be, you can significantly reduce this time from 0.134 if it's a big value down. Okay, so what I've done here, let me type return, and let me just make it like 10 so you can see. I said y is equal to NaN, which is called not a number. Okay, this is a cool MATLAB built-in function that you can just assign it not a number. I'm multiplying it by ones, okay, of length n comma 1, and I'll show you this here in a second. Okay, so if you type ones n comma 1, it does an array of ones. That's how big it is. Okay, and it's the size that you put in here, 10. If you do 1 comma n, then it will do it that way. Okay. So what I did was I said, well, these are all NaNs, not a numbers. Okay. And we're going to fill those in with numbers with this equation. Okay. So when I run this again, let's make it big. Okay. It took 0.3 seconds. Now, if I take this out, it takes a little bit longer. Okay, see how much longer that is? Holy smokes. All right, so much quicker to establish. Look at that. It took almost 12 seconds without me putting this. Now watch, 12 seconds, 0.24 seconds. Okay, so we've efficiently improved how fast this loop is going by using these, because it's what's happening here is it's building. It doesn't know how big it is, so it's building that at the same time, and it just takes forever. Okay. All right, now to the big one. We're going to do projectile motion, and this will wrap up the for loop section. Okay. All right, so let's go ahead, and I got to delete some things here. Delete that, delete that. All right. So CLC, clear all, close all. And here's an example, all right? Projectile motion. We're going to define constants, define our givens. So acceleration due to gravity is negative 9.81. Define our givens. We're going to actually basically think of this as a tennis ball, and we're going to throw the tennis ball at two different angles, 15 and 30. Okay, so two different angles. We have an initial velocity of 15, initial position of 0, initial y of 0, and we're going to look at a time matrix from 0 to 60 seconds. Okay, so we're going to end up plotting the trajectory of that tennis ball, two of them. Okay, now you notice here we have a matrix here, and then we also have two angles here. So you're going to notice when we do our equations that you have to have for loops for it. Okay. All right. And you can do one for loop or two. And I'm going to show you two because we're going to do one for loop for the time because it's a matrix, if you notice that. And we're going to do one for loop for theta. Okay. So we're going to initialize like I showed you. Okay. Take that out. Okay. And I'll show you here. So initialize. So basically what we're going to do is we're going to get equations for X and Y. So X and Y. Okay. All right. And this row is going to be theta. So the length of theta, which is 2. Okay. So there should be 2 rows. Okay. And I'll run this and so you can see this. Okay. I'll make it smaller. I'll do it to 10 and I'll only do ones. Okay. And the columns are going to be time. Okay. So let me run this so you can see. X. So this first row is going to be for theta of 15. Okay. And then the second row is going to be for theta of 30. Okay. And then these columns, this first column here is going to be time of 0. And the last column here is going to be time of 10. Okay. So I can automatically change, say I want to do 45. Look. This is the correct way to program because you're just changing your stuff in your givens and it automatically updates for you. Okay. You could also change this. Say I want to go to 20 seconds. Now it's going to be 21 columns, but 3 columns. All right. That's why I put the length of theta and the length of t here, because it automatically updates for you, which is fantastic. Okay, it's the correct way to program. Oh, let's just go to 60 and let's just do 2 angles. All right. Okay. So just for reference, so you can have that. Right. This is what I just told you. The first row, okay, which is 1 comma colon, is for 15 degrees. Okay, so I'm just going to run this again so you can see. So you got X and you got Y. Okay, go back to 10 to make sure you clearly understand what's happening here. X and Y. Okay, so I put these in here for you. The first row is X for theta 15 for all the times from 1 to 10. Okay, same thing with Y. All right, now I'll copy and paste these. We'll go through these. So I'm making a for loop for theta first. Okay. Then I'm going to make a for loop for t, and I'll put spaces on here. So again, just like we did before, we have for space I space equals. We're going to go from 1 to length of theta. So we're going to do the big loop. This is called a nested loop, the big outside loop twice, 15 and 30. Then we're going to do another loop for time, which is j, which is 1 to length of t, which is 11, right? If you type length of t, it's 11. So what we're going to do is we're going to calculate x here, then we're going to calculate x here, we're going to calculate x here, and here, and here. This is for time of 0, time of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we're going to change the angle and do it again and fill these in. And I'm going to show you how that works. Okay. And we do need 2 ends. So I like to just have it complete. And then these are where the equations are going to go. Okay. So the first, I'm going to put this. If you remember, highlight, hit Control I, it will format for you. So what we need to do, and this is just like equations, so there are going to be equations in here, and some of you may not know these, but that's fine. But I need to calculate Vx, which is the horizontal velocity, which is going to be my initial velocity, okay, which is 15 times the cosine of the angle, okay? And if you notice, my angle is in degrees. So when you do cos, you have to put the D here like we talked about before. And then I'm putting theta, but I'm putting parenthesis of I because I'm only looking at the first angle first, which is 15. Okay. So this number, when I is 1, okay, is going to be 15. Same with this. But as it goes through and it goes back up, when I is now 2, this will be 30. Okay. Now we got to calculate X and Y, and this is where it gets, you just have to understand how this works. Okay. Let's look at the X first. Let me just delete that completely. All right. And I'm going to pause this and run it slowly so you can see how it fills in. Okay. So we're going to define X, and we're going to store this, and we have to store it in terms of rows and columns, right? I, again, is this first row. Okay. So we're going to fill in this first row first, and it's going to start here, and it's going to go to here, then it's going to fill in all these, okay? Because this is what J is. So J is going to change. It's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, okay? And this is the equation that we need, which is X naught times Vx, which is from here, times time, but we're putting parenthesis of J, which is this time matrix. So every time J changes, it's going to grab this time, okay? When J is 1, which is here, it will grab 0. When J is 2, it will grab 1. When J is 3, it'll grab 2, okay? So what I'm going to do is I'm going to show you what this is, and then I'm going to pause. And I'm going to show you briefly how this works. So run it. Okay. So I just wanted to put this on here. This is where we started. We initialized that the first row is going to be theta 15, and each column is going to be the different times for X and Y. Okay. Now down here, this line 92 is where it says answer. Okay, why don't we put answer? Answer, let's do _T. Just so you can, I'll run it again. Oh, you ever want to stop your code, like I just did, hit Control-C in your command window, and it will break out of the code. Okay, all right, let's run it again. Okay, so this is getting, when I is 1, because J is 1, actually, let's put that in there. Oops, I got to break out of the code and run it. Okay, so J is 1, time matrix is 0, and look, because this is all 0, time is 0, Vx is a number, but X is 0, this whole thing is 0. It fit in this right here, okay? Now watch. J is now 2. Boom. The time is 1 because J is 2. It says, well, tell me what T of 2 is, okay, which is 1 second. And look, it filled in X right here. It filled in this. Now, J is 3. The time is 2, okay, but it's telling me find T of 3, which is actually 2 seconds because you got 0, 1, 2. That's 3. And look, it filled in here. Boom. Click enter. J is 4. It filled in this. Okay. And then I'm going to keep going. Look, it just keeps filling this top row in. It filled the top row in because we're doing the inside loop first, which is time. Time is the columns. Now, once it finishes that, it's going to get to line 97 and say, I'm done. It's going to go in between line 97. Actually, we could probably do this. Line 98 and say, we're still in the loop because we still got to do this one more time for theta of 0. of 30, and it'll start filling in the bottom values. Okay. Now, what happened is this inside loop has to restart. So it restarts at J of 1. So it fills in this position. J of 2, which the time is now 1 second, and it fills in this location. And then if you keep doing this, you can see how it starts filling in those values. Okay. So the way this is called a nested loop, and the way it works is it first establishes I of 1 here, and then it does all of this for loop first. Once it finishes that, it goes back up to the top and continues until this is completely satisfied, meaning you're going to do this 2 times. Okay. And you do the same thing for Y, and I'll paste Y in there. All right, so Y, you have I, you got J, and then you got Y naught. You got basically the same equation, but it has to do now with AY, okay? All right, so I'm just going to take that out, suppress this, and just make that, I'll get rid of that too, okay? Just so you can see. All right, so now if I run this, okay, I suppressed it, and you can kind of notice that, let me do Y. That if we scroll all the way to the top, it starts with how we established it. And then if you notice, it starts filling in these values, right? Each one of these sections here is a different J value, okay? So it starts filling in the top, as you can see here, got to here, and then it finished the inside loop, and then it restarted the theta 30, which is here, and it reset the J value back to 1, okay? And it started filling in the bottom ones, if you notice this, right? And then it started filling those in completely, okay? And then run it. Oh, and I can put, now again, a lot of this is seeing it for the first time, writing your code and seeing how it works. Understanding you got rows, you got columns, how they all line up can be very tricky. So, but you have this code, you can take a look at it, okay? Now we can plot the solution. All right, which is the first row, which is 15. So I'll run it. Okay, here's our plot. And then I'll go right to here. So we're going to plot 30 degrees, which is row 2. You have, and I put labels on here. Okay, and run it. Okay, let's see here. Maybe we need to run it. I think we need to run it for longer. Let's run it for 60. Nope. Okay. Let's just check this out and see what happened. I got it working earlier. Oh, there we go. Okay. So here's our 2 lines. And obviously, if we threw the tennis ball, they wouldn't really yeah, they're not going to go that far, right? Okay. Now, if you notice here, you see how these lines are choppy? It's because I'm missing some of the data points. So I'm going to go up here and go by 0.001 and run it. Okay. It was missing a lot of the initial data, and if I take this out, you'll see that we grab this data, right? Because some of this is not like it's less than 1 second, right? I'll show you here. So if we do like 3 seconds, it lands in 3 seconds, right? I just chopped off all the negative values, which is below ground, okay? Even 2 seconds. So if I do 1 second, okay, the black one, and we were going by 1 second, already in 1 second would be already below ground. That's why it was missing there before. And the red one, which is, what did we do, red one? Oh, sorry, the red one is 30, okay? So that one hasn't hit yet in 1 second, but the black one, which is 15, already hit in 1 second, okay? So we can make, let's just make it a little smaller, and we'll go to 2 seconds. So sometimes you got to do that. You got to make sure your time increment is small enough to capture everything in your graph, okay? We can put grid on and run it again. This is how, sorry, line 109 is how you can put your axis limits, okay? Nice and pretty. And then the legend, you can put a legend on a graph, okay, by just typing legend, parenthesis, in single quotes, this is the first line, and then put comma, and then this is the second line. And then this is just a caret for degrees, okay? All right. Now, if you didn't want to do that, and you just wanted to do 2 different lines, you can put legend, put parenthesis, and then do a bracket, and then do num to string, and then do space, single quote, put your degree symbol, and then close that with a bracket, and then put comma, and then do the same thing for that one. That will actually automatically update your angles, okay? So you can change them in your code. And then the last thing is a title. Oops. We're using a lot of the stuff I showed you in the previous tutorials, but now we're including a for loop, okay? So all of this plotting and legends and titles we did before, matrices we talked about before, but now we've added a for loop, and understanding how to program that for loop can be very tricky. So just take a look and make sure you rewatch this, okay? So that's what I have for for loops. I hope you enjoyed. You can, you need to practice the for loops because they can be tricky. Understanding how to store values, when not to store values, how your rows and your columns work can be very tricky. But again, take care, and I will see you in the next one.